students, welcome to the new session. And in this session, we'll be discussing about the topic called ellipse. So, in the ellipse, what exactly the ellipse? Okay, so S is the focus, and if there is a directrix, a fixed line, and P is a variable point, if the ratio of SP by PM is equal to a constant which is less than 1, locus of P is going to be the ellipse. This is the locus is going to be ellipse. So eccentricity will be 0 less than E is less than 1. This is the eccentricity. So what you are going to get for this one is, when this is the ellipse, this is one directrix and corresponding foci is S, and there is a one more directrix and here one focus. This is a one focus corresponding directrix. This is one focus, this is a corresponding. So here two sets of foci and directrix will be there, and this is the center. These are the called as ends of the major axis or vertex, and this point is called minor. This distance is called length of the minor axis. So if you look at here, x square by a square plus y square by b square is equal to 1, where a is greater than b. So for this one, eccentricity is this one, center is this, and x square by a square plus y square by b square is equal to 1, where b is greater than a. In this situation, the diagram is going to be like this. So diagram is like this: eccentricity, center. Here, instead of the center at the origin, we have taken center at h comma k. So, and eccentricity of this one and eccentricity of this one will be remain same. Only thing is center at h comma k. You can shift the center to h comma k, origin to h comma k. This will be reduced to this form, and similarly, the second one is reduced to this. Okay, so and x square by a square plus y square by b square, if a is greater than b, the length of major axis along the x-axis and length is equal to 2a. If b is greater than a, major axis is y-axis, length of the major axis is 2b. Minor axis is x-axis, length of minor axis is 2a. And this one, center is h comma k, major axis parallel to x axis, here major axis parallel to y axis. Vertices are, these are the vertices. Distance between the two foci is 2ae, here in this case 2be, here 2ae, here 2b. Directrix will be this, and for this one h added, for this one k. Distance between the two foci is 2a by e, and length of lattice rectum is very much needed every time. Okay, so what will be the end points of lattice rectum? What is this one? If this is the high ellipse, okay, I'll explain every point here itself. So look at here, this is the major axis, this is the minor axis, these are the foci. This distance is AE, and from here to here the distance is A. Directrix will be here. This distance is A by E. And this is the lattice rectum. Here L dash is lattice rectum, or this is also lattice rectum. This length of lattice rectum is 2b square by A, where if A is greater than B. If B is greater than A, it will be reverse. Okay, and this point is, this is AE, AE comma B square by A. This is what we have. Parametric form is x square by A square plus y square by B square is equal to 1. So x is equal to A cos theta, y is equal to B sin theta. In this case also we'll take. But in this case what happened? Center is not at the origin, center at h comma k. So we are going to add h plus A cos theta, k plus B sin theta here also same. Auxiliary circle. What is meant by auxiliary circle? If you take the any tangent and draw the foot of the perpendicular from center foci to these tangents, you are going to get a circle. This circle is auxiliary circle. Director circle is locus of point of intersection of perpendicular tangents is the director circle. Okay. So director circle is x is concentric with the given ellipse and the radius will be under root of a square plus b square. What is meant by the focal distance? What is meant by focal distance? See, this is the ellipse. Here one focus is the point. SP is a focal distance of point P from one of the focus or this one. So how we'll do? Here the directrix will be there. SP is equal to E times of PM. Means from here to you draw perpendicular. So from here to here the distance is A by E. And if this is x1, y1, this length is x1. Am I right? So SP is equal to E times of PM, the total distance A by E minus x1. So you are going to get A minus EX1. If you take this side as the thing, when you are taking S prime P, you have to take this one. So S prime P is equal to E times of, from here to here the distance is A by E and plus x1. So is equal to A plus EX1. So that's why SP plus S prime P is equal to 2A, and if 2A is greater than SS dash, the locus is going to be the ellipse. This is the one of the way of expressing the definition of the ellipse. Okay. So here SP is equal to A minus EX1, SP prime is equal to this one, SP plus SP prime is equal to 2A. Now if this is the ellipse, any point on this one P alpha, what is the meaning of this one? A cos alpha, B sin alpha. And there is another point A cos beta, B sin beta. Now what is the chord joining these two? Chord joining these two is x by A cos alpha plus beta by 2 plus y by B sin alpha plus beta by 2 is equal to cos alpha minus beta by 2. So from here what happened now? If this is a focal chord, what is the situation? If it is a focal chord means it will be passes through either AE comma 0 or minus AE comma 0. So just you substitute the one of these points and accordingly you are going to get the answer in terms of tan alpha by 2, tan beta by 2. Okay. So very important. Just you need to substitute AE comma 0 or minus AE comma 0. Next point is, if you look at the next point, what happened? The way of writing the ellipse equation when perpendicular lines are given. So this is one and this is. For example, if this is the major axis, this is the minor axis. Here point x1, y1 is there. What is the ellipse? Where length of major axis is here, 2a, length of minor axis is 2. So from here to here you need to find the distance, and from here to here you need to find the distance. Okay. So from here to the minor axis distance. For example, if this is Lx plus My plus N1 is equal to 0, what is this line? Mx minus Ly plus N2 is equal to 0. So perpendicular distance from here to here, that is Mx1 minus, okay, Ly1 plus N2 by perpendicular distance, root over M square plus L square whole square by A square plus you need to take. So Pm, Pn. So minor axis first, major axis next. And this one by b square is equal to 1. You are going to get the equation of the ellipse will come when they have given two mutually perpendicular things. One is the major axis and another one is the minor axis. Now, x1, y1, before going to this one, what happened? No? S is equal to, I have taken this one. Now, S11. S11 is x1 square by a square plus y1 square by b square minus 1. For example, S11 less greater than 0, point lies outside. S11 is equal to 0, point lies on the ellipse, and S11 less than 0, points lies inside. And S1 is equal to 0 always represent the straight line. S11 is a constant, S12 is also another constant. And here what is the important things we need to talk about? If this is x1, y1, somewhere here x2, y2 is there. What is this chord joining S1, x1, y1 and x2, y2 will be S1 plus S2 is equal to S12. Okay. So these notations are needed. And if I want to draw the tangent at x1, y1, tangent equation is S1 is equal to 0. Now, here x1, y1 is here. Pair of tangents were drawn, touching it. What is this equation? Is also S1 is equal to 0. This is called chord of contact. Now here, what I'm doing is Px1, y1 lies outside or inside accordingly. This property already I told you. Next one is, what is the position of the, okay, S is equal to this one and the line is there. So if ellipse is here, line is here, R line is here, R line is here. So y is S is equal to ellipse is given, L is equal, y is equal to mx plus c. In this one, there is no solution for these two. In this one, when you substitute y is equal to mx plus c in this one, delta is equal to 0. Here two values will be there. So if the line intersect the ellipse in two distinct points, mod c will be less than or equal to root over a square plus b square, a square m square plus b square. Neither intersect nor touches, mod c is greater than root over a square m square plus b square. And if the line touches, mod c is equal to root over a square m square plus b square. So the condition for tangents is c square is equal to a square m square plus b square. And the point of contact is minus a square m by c comma b square by c. And if the line is, instead of y is equal to mx plus c, if the line is lx plus my plus n is equal to 0. If the line is lx plus my plus n is equal to 0, becomes a tangent to this one if a square l square plus b square m square is equal to n square. A square l square plus b square m square is equal to n square, and point of contact is minus a square l by n comma b square m by n. This is a condition for tangency is this one and point of contact is this one. Okay. Equation of the tangent to the ellipse at x1 y1 is s1 is equal 0. That is x1 by a square plus y1 by b square is equal to 1. Equation of the tangent at theta on the ellipse is x by a cos theta plus y by b sin theta is equal to 1. Equation of the tangent passing through P and slope M is given as how it will be is good. So generally y is equal to mx plus c. Instead of c, you can write this equation. Or from here passing through P, y minus y1 is equal to m into x minus x1. Okay? Or your point P is not required. Any equation of the tangent with the slope m to this equation is y is equal to mx plus or minus root over a square m square plus b square. So with the same slope, there are two parallel, two tangents. One is this side, one is this side. Or one is this side, one is this side. Okay? Now, two possible tangent from external point x1, y1 to the ellipse with what are the things you are going to get? Slopes m1 and m2. Then m1 plus m2 is equal to 2x1 y1 by x1 square minus a square, this one. So how you are going to get this one? Okay, so from where you will be getting this? Very simple. Y is equal to mx plus r minus root over a square m square plus b square. Passing through x1 y1, you write this one. You transfer this side and squaring on both sides. So you will be getting a quadratic equation in terms of m. How it will be? M square into x1 square minus a square minus 2m x1 y1 plus what you are going to get? Y1 square minus b square is equal to 0. Sum of the roots you will get, product of the roots also you are going to get. And if theta is the angle between, so it is here, these are the pair of tangent. This is one tangent and this is another tangent. If this angle is theta, tan theta is the angle between x, this one, tan theta is equal to 2ab root s11 by x1 square plus y1 square minus a square plus. Very simple. I'll be getting here m1 plus m2 value. I am getting m1 m2 value. So from here I can get modulus of m1 minus m2. Modulus of m1 minus m2 is equal to m1 plus m2 whole square minus 4m1 m2. So from there you will be getting tan theta is equal to modulus of m1 minus m2 by, okay, 1 plus m1 m2, 1 plus m1 m2. Okay, and if this angle is 90 degrees, angle is 90 degrees means locus of x1, denominator goes to 0. So locus of x1 y1 is x square plus y square is equal to a square plus b square, which is known as the director circle, which is known as director circle. Next point is the equation of pair of tangent drawn from x1 y1 to the ellipse is s1 square is equal to s into s11. Okay, s1 square is equal to s11 means if you have, this is the equation, I need to draw the this point. So s1 square is equal to, if this point is x1 y1, s1 square is equal to s into s11. The product of the perpendicular distance from foci on any tangent of the ellipse is length of the semi-major minor axis. Means you have this ellipse, you have this, right? Now a tangent is like this. So from here this product is B and this one also B. So the product is whole square. You need to write square. Product of the perpendicular distance on any on from foci and any tangent of the ellipse is this one whole square, because this is be this. And if you take this one, from this length is AE minus, sorry, this length is A by E minus AE, and from here to here this length is A by E plus AE. So you can go ahead with, you are going to get the B square. Feet of the perpendicular from foci and any tangent of the ellipse. So if you have the ellipse like this and a tangent is there, so from foci you go for the perpendicular things. So you are going to get a circle. What is this one? Auxiliary circle. What is the equation of the auxiliary circle is x square plus y square is equal to a square. If b is greater than a, you are going to get b square. Equation of normal at x1, y1 is a square x by x1 minus b square y by y1 is equal to a square minus b square, or a square minus b square can be written as a square e square. And same normal and the parametric point theta, ax by cos theta minus by by sin theta is equal to a square minus b square. If you replace cos theta sin theta with tan theta by 2, biquadratic equation will come. So when biquadratic equation is coming, what I can say is, for any ellipse from any external point, at most four normals can be drawn. At most four normals can be drawn. Okay, this is one normal. This. Okay, you can draw four normals. If this is alpha, beta, gamma, delta. So what are the other things we can look at? So at most four normals can be drawn from the external point. So you look at it from this, you can draw how many normals? Four normals. So this is alpha point, normal is passing, beta point, gamma point, delta point. Condition for Lx plus My plus n is equal 0 may be normal to the ellipse if the condition is a square by L square plus b square by m square is equal a square minus b square whole square by n square. So how can we derive? Sometimes you may not remember this. What you can do is simple. The general normal equation is ax by cos theta minus by sin theta is equal to a square minus b square. Just compare this equation with given normal equation and eliminate cos theta. So what will happen? A by cos theta is equal to m by minus b sin theta is equal to minus n by a square minus b square. So from here, cos theta is equal to, you'll get sin theta, and we all know that cos square theta plus sin square theta is equal to 1. You can simplify this. Next one. What is the chord of contact? So from external point, when you are drawing two tangents join their point of contact. This is called chord of contact. If this point is x1, y1, this equation is s1 is equal to 0. Please understand here, instead of ellipse, you can keep it as parabola, circle, hyperbola. The chord of contact definition will not change. Even pair of tangents also will not change. Okay. Now, very important thing, the reflection property. What is that? What is this reflection property? This is the ellipse. Here one focus S dash, here S is there. Now this is the tangent line, this is the normal line. Now the angular bisector of these two will be, these are the things. What happened? Any line passing through this one, because this angle is equal to this angle. So when it is going and hitting this target, it will get reflected and passes through this one. The reflection property of ellipse is this one. Similarly, hyperbola is also there. So from one focus, if the ray is going and hitting the target, maybe need not be here. If it is going and hitting here, then also it will passes through this. Okay. Next one is, if this is the ellipse, a chord is there. If midpoint of chord is x1, y1, this chord equation is S1 is equal to S11. This midpoint is S1 is equal to S11. So, what all we need to discuss in this chapter particularly means, so what all the things we need to discuss in this chapter is, when the ellipse is given, how to find the focus, how to find the directrix, what is the axis, etc. So, and one more thing I want to tell you, a general second degree equation. What is the general second degree equation? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. It may represent ellipse. When it is represent the ellipse, delta is not equal to 0 and h square minus ab should be less than 0. And what is the center of the ellipse is hf minus bg by ab minus h square and gh minus af by ab minus h square and other measurements. So, and most of the times they'll give some equation and they'll ask us to find out the foci, vertex, latus rectum, length of latus rectum, equation of directrix. These are the things. Okay. So please read those points. Okay. So with this one, I'm concluding the session. In the next session, we'll discuss some of the problems. Thank you.